Take a look at this video explaining an interesting visual experience, and then let's come back and talk about what's probably going on.
A few years ago, I ordered a really cheap pair of prescription eyeglasses off of the internet. I was outside one day in bright sunlight, and I had the electrical plug for my swimming pool in my hand. I could see through the black casing a little bit. I noticed when I was really little, we had a VCR remote. I could see the LED flashing faintly.
So first, thank you for sharing your experience, and caveat, I've never examined you, I've never met you, I can't say for certain what's going on in your own eyeballs. At the same time, I'm going to give a likely mundane answer, I'm sorry, probably not superhuman vision, to what was going on in both of those situations. The first and most important thing to understand is that when it comes to things like plastics in particular, they are very rarely fully opaque. Instead, they let certain wavelengths of light through more or less than others. In order for a plastic to look black, we just need to filter out enough light so that whatever is reflecting off of it and coming back to your eye just looks like the outside black casing and not whatever's hiding inside that box. Similarly, that's also how your sunglasses work. Certain wavelengths of light get through more than others, and that's what gives them a particular color, while you have some that are more bluish and others that might be more reddish or brownish. In the example you shared, I suspect that what's going on is the wavelengths of light that were hitting those electronics inside and then bouncing off happen to also be the wavelengths of light that those sunglasses allowed to come through most efficiently. And that the wavelengths of light that normally would give you the sense of the outside casing being black were the ones that those glasses were also filtering out. In addition, if they happen to be polarized, that could further enhance that effect, but that's for another video. And there's actually kind of a similar phenomenon going on when it comes to that IR blaster. In full disclosure, I remember seeing those as a kid more too. That's likely because there are two main categories of infrared lights that we use for remotes. One that sits around 850 nanometers, which is actually really close to our visible light spectrum, and another at about 940, which is much further away. Now we add to that the reality that the cones in our eyes don't have a sharp cutoff at that 700 or 750 nanometer range that we often say is the end of the visual spectrum. Instead, they just sharply taper off, meaning if there is enough brightness of that light, we can actually see stuff much further into the red than we might otherwise indoors or at night. So all you need is one of those 850 or so nanometer LEDs behind a piece of plastic that allows some of the visible part of that spectrum to come through, and if the brightness and conditions are just right, you'll still see a little flashing. And all of this is also a really great example of how we take complex biological systems and often create these simplistic models that are good enough, but break when we get to the very limits of them. Really appreciate the question and the video reply. As always, if you have any more, throw them in the comments below.